Find the surface area S of the portion of the hemisphere fx comma y equals to the square root of 25 minus x squared minus y squared, which is the three-dimensional hemisphere that lies above the region R bounded by the red circle, x squared plus y squared less than or equals to 9. So that is the circle. X squared plus y squared less than or equals to 9. The 9 tells me that the radius is 3. So the center is 0, 0. How do I know? Because this is a x minus 0 square plus y minus 0 square. So that's why the center is at the origin. And then the radius is 3 because 3 squared is equals to 9. So the base is a circle. Radius 3, 3. This is a negative 3 on an xy plane, x squared plus y squared. However, this function is z equals to the square root of that, so that represents the hemisphere. Okay, that's a hemisphere, which is like 3 is like half of a sphere, right? Hemisphere. Okay, what is the first step that we have to do? The surface area is equals to the double integral over the region R. This is the region R inside the circle. 1 plus the partial derivative with respect to x squared plus the square of partial derivative with respect to y. Okay, so then the first step is we will have to do the partial derivative. So with respect to x, so first of all, we will have to bring the 1/2 power down. And then 25 minus x squared minus y squared. 1/2 minus 1 is negative 1/2. And then chain rule the derivative of the radicand with respect to x. So only the minus x squared survives. That is a negative 2x. And then the 25 is a constant. The y squared is a constant. So that is equals to the 2 is cancelled. We have negative x divided by the square root. Because it's negative 1/2, we bring that to the denominator. 25 minus x squared minus y squared. And then fy, partial derivative with respect to y, we bring the 1/2 down. 25 minus x squared minus y squared, negative 1/2. And then the derivative of negative y squared is minus 2y. And then the 25, the x squared, they are all constant. That is equals to negative y, right? The 2 is cancelled. And then over the square root of the radicand, 25 minus x squared minus y squared. So at this point, the partial derivatives are done, and then you have to square that. So there is a square, right? Once you square, the square root is gone. And then you have the square root of 1 plus the square of negative x divided by the square root of 25 minus x squared minus y squared. You square this, and then you square the minus y as well, divided by square root 25 minus x squared minus y squared. Okay, extend the square root, square, and then what do I have? And then this one you will have to get a common denominator. The common denominator that I will be using is the radicand, 25 minus x squared minus y squared. And then this is a minus y squared. Oh, actually, you know what? It's no longer a minus, it's a plus, because you square the negative sign as well. And then, let me double check. So minus x minus y. You square that, you have a plus y square, and then you have a plus x square. And then how about the 1? The 1, you will have to get a common denominator, which is a 25 minus x squared minus y squared. That is the common, that is how you rewrite the 1. And then you see that the x squared is cancelled, and then the y squares are cancelled. So you have a 25 on top. You take the square root of that. That is equals to 5, right? Divided by the square root of 25 minus x squared minus y squared. And then now my surface area is a double integral over the region R. And then the region R, we will have to use the base, which is the circle, to set up the region R. And then 5 divided by the square root of 25 minus x squared minus y squared. And then we have a dA, right? Because we haven't decided dy dx or dx dy yet. Okay, the integrand is done. We will have to work on the upper and lower limit. To work on the upper and lower limit, we will have to look at the base, which is the circle. x squared plus y squared is equals to 9. How do you graph the circles? One of the ways to do it is, let's pull this up. Oh, I'm trying to move this. Let's pull this up. So we have x squared plus y squared equals to 9, right? So that means y is equals to the square root of 9 minus x squared. I know there is a plus or minus. The plus is right here. The minus is here. So the plus is basically this piece. Do you see that we are taking the square root? The square root of a quantity cannot be negative, right? So that means for the top piece, y is always positive, so that occupies quadrant 1 and quadrant 2. And then the bottom piece, the square root is positive, but you put a negative in front, so y is always negative. That will be quadrant 3 and quadrant 4, which is the bottom piece. Okay? And then what else do we have to do? I will have to draw a rectangle. So the rectangle that I would like to do is, I would like to put a point right here, and then put a point right here, and then draw my triangle. So is this a vertical or a horizontal triangle? This is a vertical triangle, right? So vertical, the triangle is vertical, so that represents delta x. So delta x, that means the outer integral is a dx. So we call this vertically. Simple. I don't know why they just call this like a vertical rectangle instead of saying vertically simple. Whatever. That is like a dy dx. How do I know it's a dy dx? Because this width, this width is, you calculate that using the x value. That's why it's a dy dx. So the delta x, that means the x is the outer integral. And then x is between where? We have x between negative 3 and 3. Just look at the circle. And then y is between what? Y is between the 9 minus x squared on top, and then the negative square root y, no, not y, 9 minus x squared, and that is on the bottom. Just like when you study the area between curves, top curve, bottom curves. Okay, that we set up the integral. So let's follow the color code. So we have the surface area equals to dx dy, right? So x is between negative 3 and positive 3. And then we do another integral. Y is between negative square root and positive square root. And then y equals to positive 9 minus x squared. Okay, let's make that look like a square. And then you just put the integrand. The integrand is 5 divided by the square root of 25 minus x squared minus y squared. And then now the differential is dy dx. And then for dy, you will have to figure out the way to take care of the y. Is this easy or hard? I will say this is not easy to do. So that's why I picked this problem for discussion. So this one is hard to integrate. So that one is hard to integrate. So I will try to convert to polar coordinate. So convert to polar coordinate. If you know how to integrate, just do it anyway. But the second purpose of this problem is I'm trying to integrate this double integral from rectangular coordinate to polar coordinate. If you know how to do the integration, do it. We will get the same answer anyway. So when you convert to polar coordinate, you have to recall a formula that for the conversion, which is x equals to r times cosine of theta, y equals to r times sine of theta. And then we have to convert the denominator of the integrand. So the denominator is 25 minus x squared, which is r squared, times cosine square theta, y squared, that will be a y squared, and then sine square theta, and then that is equals to the square root of 25, and then minus r, you factor this, right? So that will be a cosine square theta plus sine square of theta, which is equals to 1, and then the denominator is 25 minus r squared. So what is this equals to? You can state this one more time. So the 5 divided by square root of 25 minus r squared. This is no longer f of x comma y. This is now f of r cosine of theta and then r of sine of theta. This is a polar function. This is a polar. This is in polar now, no longer in rectangular x comma y. And then what else? I see that the circle occupies 4 quadrants, right? So the circle occupies 4 quadrants. So we have the circle in 4 quadrants. So circle in 4 quadrants. That means the theta is between 0 and 2 pi. That is the 4 quadrant. And then what about the radius? The radius is between 0 and negative 3. R is between 0 and negative 3. Positive 3. Okay, positive 3. And then you set up your polar, the double integral. So we reach to a page break. So that S equals to double integral over the region R. The formula is you have the function R cosine of theta, R sine of theta, and then you multiply R and then dr d theta. Okay, let's do it. So we have S equals to double integral dr d theta. Theta goes from 0 to 2 pi, and then the r goes from 0 to a 3. And then we have a 5 divided by the square root of 25 minus r squared, and then you have a multiply by r and then dr d theta. What can we do? Integration, I can see that we have to let u equals to 25 minus r squared, and then du equals to negative 2r dr, right? 1 over negative 2r du equals to dr. So that one is going to help me to do a change of variable. So change of variable from here to here. That is how we change the dr. And then what about the upper and lower limit? The u when r is equals to 3. That is 25 minus 9 equals to 16. The lower limit when r is equals to 0, that is 25 minus 0 equals to 25. When you do a u substitution, sometimes it is normal to have the upper limit less than the lower limit. It is fine. So we have equal from 0 to 2 pi, and then this will be u equals to 25, u equals to 16. What else do we have? We have a 5 divided by u to the 1/2, and then multiply by r, and then a change of variable 1 over negative 2r, and then a du, and then you have a d theta. Some cancellation. The r is cancelled, right? What else? That's it. You can pull the negative 5 over 2 out. Let's do it. So from 0 to 2 pi, you have a negative 5 over 2. Okay, negative 5 over 2. And then that will be u to the negative 1/2, right? So u to the negative 1/2. Negative 1/2 plus 1 is positive 1/2. Reciprocal is 2, such that u goes from 25 to 16. And I can see that these 2 cancels with that 2. And then continue. You have from 0 to 2 pi, negative 5. And then that will be the square root of 16 minus square root of 25, which is 4 minus 5 equals to negative 1, right? Equals to negative 1, right? So you have a 5. From 0 to 2 pi, you have a 5 d theta. So that will be just 5 times theta from 0 to 2 pi, which is 5 times 2 pi minus 0, which is equals to 10 pi. This is the surface area. Surface area of what? Surface area of the entire hemisphere. Nope, not at all, not at all. So let's bring this graph up. Where is the surface area? the whole green surface area? That is not true. So here is the surface area. The base, the region is right here. That is the circle. They have a less than or equal to 9, so that means they are talking about this region. Okay, so they are talking about this region. Okay, the way we do it is this one we can store a cylinder because we are trying to match this. So let me duplicate this circle. We are trying to match this. Okay, so that one looks like a cylinder. That one looks like a cylinder, right? Do we agree? That one looks like a cylinder. And then you cut right here. So it's like you just like slice right there. So you slice right there. Do we agree that after you slice like that, you will get this kind of object in green? It will just look like this, three-dimensional. Three-dimensional. It looks like that, right? And then this is the surface area. That will be like this surface area. It's not the flat surface area above the cylinder. It's the surface area of this green plane. So this is a 3D object, just like a piece of glasses. Okay, and then the surface area of that object. So it looks like that, but three-dimensional is equals to 10 pi. That is the surface area, not the cylinder, not the entire hemisphere, just this little piece above the cylinder. Okay, so it's like that. It is not flat at all. That is the surface area that we are looking for. It must be above the region. Okay, that is the end of this problem and this video. If you like the way I explain surface area, give this video a thumbs up, subscribe to my channel for more contents like that. As always, I will meet you all in the next lesson for more multivariable calculus stuff. See you there.